Okay, hello. It is the period that most of us should keep social distance at home, and I wish you healthy and happy period during such a hard time. The good thing is that we have more time to read and think. That should be a precious moment for us to improve ourselves without too much intervention. Okay, let's begin today's paper reading. This paper is Learning Multiagent Communication with Backpropagation. An interesting and inspiring paper in multi-agent reinforcement learning area. We first check their motivation and then we dive into the methodology. This paper focuses on multi-agent case, specifically the agents cooperate each other to achieve one goal. But it should be pointed out that there are multiple schemes for such a reinforcement learning case, and this paper will focus on how to learn communications among agents, and then take actions to achieve one goal. Now here is their solution. Given J engines here, this is the J engines, and they cooperate to achieve one goal. Each engine receives reward signal independent of their contribution. Thus, they all achieve one goal, and no matter who achieves this goal, they all receive the same reward signal. That's the basic problem setting of this paper. And then the solution is that they want to learn the transmission signal for communication. That is, the engine will communicate to each other in the form of this communication signal, and then they achieve the final goal by cooperating. Now we dive into the detail of this model. First, we can say that this is the overall model called ComNet model, and actually like traditional reinforcement learning, they receive state representation and they output the action of each engine, and the critical thing is that here each block corresponds to the state information observed by one engine, and they try to pass information among engines with this model. So how they achieve this target? The fundamental thing is that they design such a model for each engine. In this model they consider two input for each engine. One is the hidden state from themselves. The other is the hidden state that incorporates the information from other engines. So this vector indicates the communication signal among engines. For example, for engine J, by the way, there are multiple steps of communication. That is, they may introduce the communication in multiple steps. So just like a multi-layer neural network is very similar. So for this model, we can see that they model the state with communication scheme. This is the communication signal, and this is the signal that passed from last time step by the same engine. So the actual state for engine J in I plus one step is equals to the neural network like function here. That is, the input is the hidden state from the engine itself, and the hidden state from other engines. And the hidden state from other engines is calculated in this way. It's really straightforward, right? It is just the hidden state from other engines, except the engine itself. So in this way, they achieve the communication among engines. I think it's very straightforward, interpretable, and very easy to implement. So, to take a step further, we can generalize the communication with multiple steps, and we formulate it in a vector form. So, for the I+1 step, the information from each engine can be calculated in this form. It is just like the same as this, but it calculates for multiple engines to make the formula more comfortable to read. And this is the weight matrix. If you can see the first row and this column, we can see that it is just the same like this. So it is so they encapsulate this communication scheme just like a traditional neural network things. And then here is some extension of this model. The first is that we can determine the communication zone. That is, we do not necessarily consider all other engines to communicate. We can just focus on a certain area of engines. So the number of engines to consider can be determined by yourselves depending on the problem you are solving. And then there are some also architecture extension. You can use the INOLSTM neural network to achieve the communication through multiple steps. That is, replace the multi-layer neural network with a LSTM network. It's also very straightforward. And that's all. Thank you for your attention. And I hope you all have a big progress during this hard period, and I think the COVID-19 will pass soon in the future, and I hope we will stay at home and keep us healthy and better during this period.